Hello, my dear students and the rest of the learners. Welcome to part 5 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this tutorial, we are going to be looking at what we call the input and output statements in a C program. My name is Meme JM, or you can simply call me Emelisop. Statements in C includes variables and constant declarations, the input instructions, output instructions, and the processing instructions. Each statement must be terminated with a semicolon. So let's look at what we call the output statements or output instructions. The two main functions used to output information are the printf and puts. In other words, my dear students and the rest of the learners, if you want to display any statement on the screen, whether a string literal or a value from memory, you need to make use of the ones or reserved ones, either printf or puts. So the two types of output instructions are those that are used to display statements that either instructs the user to perform a certain task, or what we call the interactive statements, or just inform the user about what is being done. The message is usually enclosed in double quotes. Its syntax is usually as follows. The keyword, printf. Then we have the parentheses. And then the message you want to display on the screen, enclosed in double quotes, and the statement is supposed to be terminated with a semicolon. For example, printf, what is your name? So their statement is simply telling the compiler or the processor to look at the monitor, search for the monitor, and write out the statement. What is your name? So the text, what is your name, will be displayed on the screen. Another example is, how old are you? These are some of the statements that we have been encountering in our previous presentations, which we have been learning from part 1 of part 4 in this series. And therefore, these are not new terms. The only thing we are doing in this presentation is simply to inform you what those statements were all about and how they were being interpreted or executed by the processor or the compiler. The second type are those that are used to fetch some contents from memory and output them to the user through the screen or to other output devices such as hard disk. In other words, other than having statements that are displayed on the screen for interaction or to tell the user what he or she is supposed to do, we can also write out information from memory to the screen or to a file. So the syntax of such statements are printf, then parentheses, and the most important part, my dear students and the rest of the learners, for you to note is the type identifier, which tells the processor the type of data that is expected to be displayed on the screen, followed by the name of the memory location where that data can be found. For example, printf followed by the ones or followed by the type identifier. So this is type identifier for the content in the memory location called your name. Then the next is type identifier for the content in the memory location called future age. So if you want to make use of a single statement, but to display various values in various memory locations, you should always organize your identifiers in the order in which the contents in those variables will be displayed. So this first identifier, type identifier, must match with the first name of the first memory location. This second one must match with the value in the memory location called future age. So the syntax or the format for displaying content from memory is the reserved one or the keyword printf, followed by the parentheses, then followed by the type identifiers, and then the list of the variables or the list of the memory locations in which those values will be gotten from. You can also make use of what we call puts. Now, puts is always good when it comes to writing out values from memory location, which is in form of text. For example, puts your name, then semicolon. So we have already looked at those statements or the way of writing out data from memory to the screen. And these are the set of statements that many students usually miss. The type identifier must match with the data type. So every data type has a specific type identifier. So the following are some of the type identifiers that are used in C and the data type they represent. So we have data type and type identifier. Character data type. The character data type, which is type char, is type identifier is %C. This is read as one identifier for C. Then we have string. It is, that means if you want to display an array of char, then the type identifier you need to use is %S. I'll read it with only one letter. The integer is D, %D. Remember, it is read as a single identifier. For long integer, %LD. For short integer, %HD. For double or long double, we have %LF. For float, %F. Floating point number with an exponent, %E. So those are the type identifier. So if you are going to have an output statement that is supposed to read or to write out a value from memory to the screen of any of those types, you have to make use of those type identifiers. And remember, we use the type identifier not just for the purposes of writing, but also when it comes to reading. That is the scanf, as we are going to see. So if you are displaying several variables using the same output statement, make sure that you match the type identifiers with their respective variable names and you position the type identifiers at the positions you would like each value to be in the output statement, just as we have seen. An example is %S, then karibu usome C programming. You can see where the type identifier is. That is where the content in the memory location called your name will be placed. So the type identifiers positioning in an output statement is key, because that is where that value will be displayed. You can also see in this other statement, you will be, now where we have the type identifier for the integer, that is where the value in the memory location called future age will be displayed. So if the content in the memory location called future age is 20, the statement will read, you will be 20 years old, 10 years from today. So the output using printf can be formatted by adding an only negative number between % and the character that follows in the type identifier to specify the width of the output. In other words, what we are saying, my dear students and the rest of the learners, is that you can format your output by specifying the size or the number of characters that would like to be displayed. For example, if you want the maximum name, even if in the memory location you have a name which is bigger, but you want the next maximum number of characters to be displayed to be 20, for example, then you can format it as follows. Instead of just writing %s, you can specify the size there. And then that means that when the processor or the compiler reads the value in memory location equal to your name, that value, if that name is more than 20 characters, the maximum number of characters to be displayed will be 20. So that is formatting. And then you can see here between %3 and D, and 3D, we have 3. Simply that means you are telling the compiler from the value which you have read in memory location called future age, ensure that you don't display that value more than 3 of its characters. So that is formatting. That is formatting. So you can always format your output. If it has decimal places or decimal points, you can also format. You can specify, like the number of the value for score should not exceed 3 numbers or 3 digits. While for mini score, we are telling it the maximum number of characters total, inclusive of the whole number section and the fractional part, should not exceed 7. And for the fractional part, they should not exceed 2 numbers. So, my dear students and the rest of the learners, it's important for you to know how to format your output because that will make your numbers or your output more readable. Though output inside double quotes in the printf statement displays the string exactly the way it is specified, the use of escape sequence modifies the way the output is presented. In other words, other than formatting the values picked from memory locations, whether whole numbers or decimal points, you can also decide to format your output on the screen. That is how your text is spaced on your screen. And you can also decide to make use of other type of characters. Like you may want to produce some sound. You may want to create equal spaces, the tab, etc. So that's why we are saying that though output inside double quotes in the printf statement displays the string exactly the way it is specified, you can make use of what we call escape sequence characters to modify how the output is presented. So escape sequences are what we call non-printing characters. And the following are some of the examples of escape sequence characters that you can make use of their meaning. So in your statement, if you have printf and then you have the \n, this is read as a single character. It is called a new line escape sequence character. When you add it on your statement, it simply takes cursor to the next line on the screen. Then we have the \t. It creates what we call an horizontal tab space. It can be placed anywhere in the string. We have \v or v, escape sequence. V, it indicates or it creates what we call a vertical tab space between your output. If you want to produce a bell, you add an alert bell and that escape sequence character. You can also add a / using that character, a single quote, a double quote, a question mark, etc. Now let's then proceed and look at what we call the input statements or instructions. What are input statements? Input statements are statements that instruct the computer to read data from an input device or a file into the memory. When you type a value, you have to press the return or what we call the enter key to confirm input. The computer then stores each input into a variable in the memory. So the two main functions that you can use for reading your input are the scanf and gets. What is gets? Gets is used when inputting a string variable and allows spaces to be included in the input. It is very useful when reading strings or array of characters, such as full names that have spaces as a single variable. It accepts only one variable at a time, and the syntax is as follows: gets, parentheses, variable name, semicolon. For example, gets your name. Then the other function we can make use of is scanf. Scanf is used when reading one or several variables as a single statement. Its syntax is as follows: scanf, then type identifier, closed in double quotes, comma, then the address, memory address operator, variable names, and then terminated into a semicolon. For example, scanf %d, then memory address for score and memory address age. What does this mean? This simply tells the compiler to read the value which has been entered by the user and assign it in the memory location called the age, and the other value assign it in the memory location called the score, and those values should be of type integer. Then this other one also is telling it to read the value which has been entered and assign it in the memory location called the age, but ensure that the value that is being stored does not exceed 3 numbers. So the memory address operator, which looks that way, stores the value entered in the memory address specified by the variable name. If you are to read several variables using the same input statement, it's always important to make sure that you match the type identifiers with their respective variable names. For example, if you are going to read two values, one to be stored in memory location called the age, and the other one to be stored in memory location called the score, ensure that the type identifiers match the order of the variables. So the first type identifier will be for the first value, and the second one will be for the second value. So that arrangement is key, so that the correct values and data is read and the value stored in the appropriate memory locations. So the following is a sample program implementing the input and output statements to calculate an employee's net salary, whereby gross salary is taxed at a rate of 14%, then display the basic salary, tax rate, tax amount, and net salary on the screen. So as usual, we have our comment program for calculating net salary. And then hash include string.h, then int main, we have our opening parentheses there, and then we are declaring a memory location whose content will not be changing, and that memory location is called double rate. Const double rate equals 0.14. In other words, what this statement is doing is that it is telling the compiler to set a memory location assigned called the rate, whose content is supposed to be of type double, and the value stored in it should not be changing, and that value is 0.14. Then the next is we are declaring variables, variable or memory locations called gross, tax, and net. whose content is of type double. The next statement is we are prompting the user to enter the gross salary. So the statement, enter the gross salary, will be displayed on the screen and the cursor will be taken on the next line waiting for the value. Then the user keys in a value. That value, which can have a decimal point, is rent, and then that value is assigned into the memory location called gross. The next statement tells the compiler to pick the value in the memory location called gross. Pick the value which has been entered as the gross salary multiplied by the value which is stored in the memory location called rate. So if, for example, the gross amount entered is 3,000, that will be multiplied with 0.14. So it will be 0.14 times 1,000. If the value entered is 3,000, it will be 0.14 times 3,000, and the results will be stored in the memory location called tax. Then the next statement is telling the compiler or the processor to pick the content of the memory location called tax, subtract that value from the value in the memory location called gross, and the result, assign them in the memory location called net. The next statement now is to display the following ones on the screen spaced appropriately. So this statement is telling the compiler to display the following on the screen. One, go to the next line, then display the text gross. Then place two tabs or write out two tabs. Like it is like saying create two spaces in between. Then display the word tax. Then create some more two spaces, display the word net, and move to the next line. The next statement is now displaying the values. So how are these values being displayed? The values are being displayed this way. So this statement is telling the compiler, go to the memory location called gross. Read that value which is there and display it on the screen with a maximum of 6 characters, but out of the 6, 2 be reserved for the decimal point. Next is create 2 spaces. So from the value which is displayed, create 2 tabs. Next, go to the memory location called tax. Read the value which is there and write out on the screen formatted as follows. The maximum size should not exceed 6 digits, and out of the 6, 2 should be for the fractional part. Then create 2 spaces. Then move on to the next memory location called net. Read the value which is there and write it out on the screen formatted as follows. Its maximum number of characters should be 6, and 2 out of the 6 should be reserved for the fractional part. So my dear students and the rest of the learners, that's how that statement will behave. And then, once that is done, the compiler will return the control back to the operating system and end the program. So let's go to this program that we are going to discuss in Falcon so that we can see whether this program will behave as I have explained. Note that this statement contains the following, or this program indicates the following. 1, the comment. 2, the preprocessor directive. 3, the main part of the program. Then declaration of a constant. Then declaration of variables, memory locations. Then we have output statement. we have input statement. Then we have operational statements. These are operational statements. Then we have an output statement, which displays the ones on the screen directly. Then we have another output statement, which displays content from memory. And then we are turning control back to the operating system and ending our program. So let's code this program in C, that is using Falcon IDE, and then we see how this program is going to behave. So let's launch our IDE. So under search, we type Falcon. Falcon. Then we click on its icon there. And I want to repeat this or mention this. It's not a must that you make use of Falcon. You can make use of other IDEs like Microsoft Visual Studio, C++. It can be used, but you must remember to save your program with .c extension. However, use of Falcon is quite easy and simple. It is easy, simple, and the app is light. So I still advise for you to make use of Falcon IDE. So once you have launched your Falcon IDE, you click on File, point on New, then click on Project. Click on Empty Project, then click Next. Under project name, call it Net Salary. I will call it Net Salary. Then under compiler type, you can click on C. Then you click on Finish. So as you can see, we have now our project name. The next thing we need to do is to create our file with this project. So you right click on the name of the project, point on new, and then click on C file. Then you can see we have main.c. You rename it to match the task you want your file to perform. So I'll write here, computing salary. That's the name I want to give to my program. And then I can click outside there. So you can see the name of my program is computing salary.c. That's the name of my file. And it is here. And note, it is under net salary project. Always remember, place your files within a project. From there, we now have our IDE, we have our editor for our Falcon IDE. So under this now, under this space, you can now type your program. Or if you have already written it, for example, using a 1D processor, you can just copy your program and paste it here. So how do we go about it? So what you are going to do, my dear students and the rest of the learners, is I'll just paste my program here, which we have already discussed. The one which I've already gone through in my presentation. So this is our program. And remember, you can always type it directly in your IDE. But as I've said in the previous presentations in this series, it's not a good habit to code your program directly in your editor or your IDE. It's good to write it on paper, write it in exercise book, play around with it, try run it, test it on paper, then just code it or transfer what you have already tried to execute in your IDE for the purposes of seeing how it is going to execute or behave. Now, once you have coded your program, you can save it. So click on the File menu, and then you click on Save. And then, if you are saving for the first time, you'll be taken to the dialog box called Save As, or Save As dialog box will be displayed, under which you can browse where you want to store your file. So I want to keep my files in my default, in my C folder, which I already selected at the beginning of this series of presentations when we are creating our file. And then you can just give it the same name or change the name, but it's advisable that you save it by the name of the project. So if the name of the project is net salary, save it as net salary. So you click on Save. From there, you can now run our program. Remember, once you save a project, you have saved your file because the file is stored inside the project. That is why if you click on the File menu, you can see that Save is already in gray. It's not active because we have already saved it. So let's compile our program. So you click on Run, then click on the Compile. You can see that our compilation is successful, meaning our program does not have any errors. Note, we have the comments, we have the proportion directive because you are going to make use of our screen and you are going to make use of the keyboard. We have the main function for every C program. We have the body of our program, which is composed of declarations. Then we have the output statement. We have input statement. We have the operational statements. We have the output statements here. So those are the type of statements that our program can have. We have the declaration statements. We have the output statements. We have the input statements. We have the processing statements. So let's now run our program. So once you click on Run, you can see we have been taken to the output screen. So the first statement is requesting us to enter the gross salary. So let me type, for example, 9,780 as the gross salary. So once I press enter here, remember our rate is fixed. So to compute the tax, it is the gross salary multiplied by the rate. As you can see, that tax equals rate times gross. So whatever is in gross will be multiplied by 0.14. The result will be stored in tax. Then net salary will be gross minus the tax. So what we expect to see once I press enter is the program will display gross as an heading, tax as an heading, then net, and then the values under each. Under gross, we are going to have gross value. Under tax, we are going to have the tax. Under net, we are going to have the net. That will be done automatically once I press enter. So let me press enter. You can see. So gross, 9780. Tax, 1369.20. Then net is 84.10. Now the question is, if you look carefully at our salary, what we are going to get is short of the tax. So if you are paying 97.80 and the tax is 1369, it means the amount to be received will be less. That's exactly what you can see on the screen. And that's how our output and input statements, as well as declarations and the processing statements, behaves. So I'm going to press enter key, go back to our program, and then you can click on save all to save your project and the file. And then you click on close all to close our program. And then you can click on exit because we are done. And with that, my dear students and the rest of the learners, we have come to the end of part 5 of the series. You can now proceed and listen, watch, and practice on part 6 of the series, in which we are going to be explaining about the processing statements and operators, which of course we have already been using in this presentation and also in the previous series of presentations. Congratulations, therefore, for learning part 5 of 29 on input and output statements in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 6 of the series, and God bless.